Hi students. Today I'll be explaining you about a formulation of LPP and obtaining optimal solution by using graphical method. So here I've taken an example. Uh, a company produces two types of hats. Each hat of type A requires 2 hours of labor time and each hat of type B requires 1 hour of labor time to make. The total available labor time is 500 hours per day. Maximum 150 hats of type A and 250 hats of type B can be sold in a day. The profits on hat A and hat B are rupees 8 per hat and rupees 5 per hat respectively. Maximize the daily profit of the company. Now, if you look at the objective of this question, the objective clearly says the objective clearly says maximize the daily profit of the company. Now, whenever you have to formulate an LPP, that is linear programming problem, you need to target the optimum objective function. So the aim of this problem is to maximize the profit. So let's step one. Step one. So here now, if you look at the last sentence, the profit on hat A and hat B are rupees 8 per hat and rupees 5 per hat. That is, by selling one hat of type A, you get 8 rupees profit, and by selling one hat of type B, you get 5 rupees profit. Now here let's, and first step is to identify the decision variables, and you can identify the decision variables only through the objective function. So let's formulate the objective function first. That is objective function. So objective function is what? So I'll write here. So profit function. Now, so this is equal to, the profit function is equal to, so you get 8 rupees profit by selling 1 unit of hat A plus, and you get 5 rupees profit by selling 1 unit of hat B. Now profit depends on how many units you're going to sell in a day. So let X represent number of hats that you are selling in a day of type A. So when you sell X units of type A hat, or X number of type A hat in a day, you get 8 into X rupees profit. Okay, and if you sell Y number of hats of type B in a day, you get 5 into Y rupees as the profit from hat B. Okay, because 5 rupees per hat and you are selling y number of hats, so 5 into Y will be the profit that you get from hat B, and 8 rupees per hat of type A. So if you sell X number of hats of type A, you get 8 into X as the profit from hat A. Now collectively it is 8x plus 5y. That is, the total profit that you get from both the hats, that is hat A and hat B, is 8x plus 5a. Now this is the objective function. Now what is the objective? To maximize this profit function. So max of profit function. Now you will write the decision variables. Let X and Y represent the number of hats of type A and B sold in a day respectively. Now, so coming to step 3, that is subject to constraints. Now this is where we write our conditions. So we have so many conditions in the question. So let's go one by one. So a company produces two types of hats. Now each hat of type A requires 2 hours of labor time. That is, to make one hat of type A, you need 2 hours of labor time, and to make one hat of type B, you need 1 hour of labor time. And if you see that, the next sentence says the total available labor time is 500 hours per day. You have only 500 hours in a day, so within this time you have to make the two types of hats. Now let's Right, so to make one hat you need 2 hours. Okay, to make 1 hour you need, so this is for type A and this is for type B hat. Now if you are making x number of hats, you need 2x number of hours to make x number of hats, and if you are making y number of hats of type B, you need y number of hours to make the hats of type B. Now collectively 2x number of hours to make y number of x number of hats of type A, and y number of hours to make y number of hats of type B. Now total time is nothing but by adding the total time taken to make both the hats you get, and that should not exceed the available time. So available time is, so that should not exceed the total available time, so that is the total time consumed to make both the hats should not exceed the available time, that is 500 hours. Now this is called time constraint. Now so let's, okay, let us go to the next condition given in the question. So the question says the maximum 150 hats of type A can be, and 250 hats of type B can be sold in a day. Maximum you can sell 150 hats of type A and 250 hats of type B. So X represents number of hats of type A that is sold in a day. So X represents number of hats uh, of type A sold in a day. So that should not exceed what, 150. Okay, and again Y represents number of hats of type B sold in a day, that should not exceed how many hats, 250 hats. It clearly says it is 250 hats maximum that you can make. So hence the number of hats made, or number of hats made and sold should not exceed 250, that is of type B. So hence our Y should be less than or equal to 250 hats. Okay, so here, so let's see if any other constraint is given in the question. So 250 hats of type B can be sold in a day. The profits on hat A and hat B are given. So this we've already considered in the objective function. So everything is considered. So if we consider objective function, we've considered 3 constraints or conditions given in the question. Now this is step 3. So next is step 4, that is non-negativity restrictions, that is NNR. Now that clearly says that since X and Y represent number of units or number of hats, they cannot be negative, that is X and Y should be greater than or equal to 0. So this is formulation of LPP. Okay, this is linear programming problem. Now let's see how to obtain the optimal solution, or or the maximum profit by using graphical method. So next is using graphical method, we're gonna obtain the optimal solution for the formulated LPP. Now next is graphical method. Now first step in graphical method is to 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 consider only equality in all the given constraints. So we will list out the constraints one by one, and we'll consider only the equality. So we'll neglect the less than or greater than symbols. We'll consider only the equality. Now which are the first constraints? First constraint is so 2x plus, so 2x plus y is less than or equal to 500. This is our first constraint. When you consider only equality, you get excuse me. So when you consider only equality, you get 2x plus y, and that is equal to 500. Now this clearly represents an equation. It's a linear equation because the power of x is 1 and power of y is 1, so and that is equal to 500, and this clearly represents a linear equation, basically a straight line, linear. So that is a line. Okay, now we have to plot this line on the graph, that is on xy plane. So first, to do that, we need to find 2 points through which this line passes. So first is to find that, so x and y. Now when you put x as 0 in equation, I'll just name this as equation 1. So when you put x as x0 in equation 1, so what do you get when you put x 0 in this equation? So when you put x as 0 in this equation, you get 2 into 0 plus y is equal to 500, and that gives you y is equal to 500. So when you put x as 0, you get the value of y as 500. Okay, so this is not required, this is just for understanding purpose. You can write the numbers directly in the table. Now when you put, next step is other way around. When you put y as 0 in this equation, when you put y as 0, you get x as 250. You get x as 250. Now we have 2 points, that is, one is x comma y, that is equal to what, 0 comma 500. Another point is x comma y, that's equal to 250 comma 0. Now these are the 2 points that we have for line 1, that is equation 1. So we're going to plot these 2 points on the graph, then join them by using the line, and that gives you the equation of this line. Okay, so we have done for first constraints. Now let's consider the second constraint. Where is the second constraint? It says x is less than or equal to 150. So x is less than or equal to, this is the second constraint, this is the second constraint. So x is less than or equal to 150. So we have considered that 150, less than or equal to 150. And when you consider equality, you get x is equal to 150. Okay, now since we do not have another variable here, so we just keep it as it is. So here, this is your equation 2. Now we cannot use this method as we don't have another variable. We have only since we have only one variable, we just stop it. So we leave it as it is. Now next step, we consider the second constraint, that is y is less than or equal to 250. So again, consider only equality, you get y is equal to 250. And here again, we have only one variable in the constraint, so we don't do anything, we just write the equality symbol, that is y is equal to 250, and leave it. And this is your equation 3. Now we're gonna plot all these points on the graph and join them using the lines. Okay, I'll draw here. So y-axis, excuse me, so x-axis and y-axis. Okay, now let's look at the y-axis range. So y-axis values, the maximum value for y is 500. If you look at this, 500. So we'll take along y-axis in terms of hundreds. So this is 100, 200, 300, 400, 500, then 600, and so on. Now along y-axis we have taken values, and then along x-axis we have to take the values, maximum value that x can take is 500 here as well. So we'll take in terms of hundreds. So 100, 200, 300. When you are not drawing it on the graph, make sure that the length is equal so of each unit. So next is 400, second one is 500, 600, and so on, it goes on. Okay, now after this, now let's plot the first equation here. So these are the 2 points that we have. Okay, so we're going to plot these 2 points and then draw a line. Okay, so we'll plot those 2 points and join it. Now where the first point is this, so this is our first point. So 0 comma 500, that is x is 0 and y is 500. Now this part is called 0 comma 0, and here since we are considering only this part in the graph, the reason is here in this area and this area the values of either x or y is negative. So in this area, this below the L shape region, that is here, this part, your values of x or y, either x or y, will be negative. But look at the last constraint here, and in our says x and y should be greater than 0, and that is the and this part is the only place, this is the only place where your x and y is greater than 0. Only this place, x and y is greater than or equal to 0. That's why we're considering only above the L. So now I'll erase just. So we will be, so our region will be here, so only this part will be considered. Okay, I've drawn the two axes and I've considered the points along the two axes, that is starting from 100 to 600 and so on, and again along y axis starting from 100, each unit is of length 100. Now let's draw the lines that we have calculated in the in step 1, that is we have equation 1, that is 2x plus y is equal to 500, and we have 2 points for that line. So this line 1 passes through these 2 points. Now let's plot these 2 points, this and this, on the graph and join them by using a straight line. So 0 comma 500, that is x is 0, x is 0 and y is 500. So x is 0, this is 0 comma 0. Now here x is 0 and y is 500. So here x is 0 is here, 500, y is equal to 500. So this is the point. So I'll use some other color. So this is the point. And now next is what? X is 250 and y is 0. So next point is x is 250 is here and y is 0. Now we're going to join these 2 points by a line. So we're going to join this by a line. Now here, so this is nothing but so this is equation 1. So this is equation 1. So this is equation 1, that is 2x plus y is equal to 500. 2x plus y is equal to 500. Now, so we've drawn the equation. Now let's shade the region. Now clearly this says it is less than or equal to 500. So less than or equal to 500 means the region will be towards the origin. Just towards the origin means it will be below the line. So I'll use some different color to shade the region. So that is towards the origin, that is below the line. This is for first constraint. So we drew the line, then we are considering the inequality now, that is less than. So we've shaded the region. So next we'll consider a second line. So here if you consider line 2 is x is equal to 500. Now where is x is equal to? X is equal to 150, excuse me. So x is equal to 150 is here. Now you will get a line. So x is equal to 150, but they're not given the value for y. So y doesn't exist in the equation, so here x remains constant, y can take any value. So x is equal to 150 is here, and y can take any value. So you get a line that is horizontal, that is perpendicular to x axis and parallel to y axis. Get a line. Okay, so now since it says x is less than or equal to 150, that is this, so the area will be towards the origin, that is again below the line. So I'll use another color for that. So I'll use some spirals to shade that. Okay, so we are done with two lines. So this is equation 2. So now we have to consider the last equation, that is equation 3. Now it is y is equal to 250. So now we'll draw y is equal to 250. Now y is 250 is here. Okay, y is equal to 250 is here. So x can take any value because x is not in the equation. So we will get a line. So y is constant. So y is constant. So y is constant. Get a line like this. Okay, now here again we'll use some other color. So it is again less than or equal to 250, so it will be below the line, so towards the origin. So the origin is here, towards the origin, below the line. So I'll use vertical lines to shade region. And so on, it goes on again. Now we have to identify the region which has all the three patterns or three shades. Now I'll darken the region because we can't consider this one as only two regions. Now so I'll highlight it with thick white line. I'll use green color to highlight the boundaries of. So this is the region. That has all the three shades. Okay, now this is the region that has all three shades. So I'll highlight the corner points with red colors. So we have one point here, we have another point here, another here, another here. Now these are the corner points of the feasible area, and this is our feasible area. So I'll make it green. So this is our feasible area. So this part is our feasible area. Now we have to find the corner points in this feasible area. Now I'll name the points as, this is A, B, this one is C, this one is D, this one is E. Now we have 5 points. Now we have to find all the points. Now what is A? A is nothing but our origin. B is what? B is nothing but 250 comma, sorry, okay, B we do not know. B is nothing but 250, Y is 250, 0 comma 250 is your B. So 0 comma 250 is point B. C we don't know, C is question. D also we don't know, D is question. Okay, This is question, this is question mark. We don't know what D and C are. Now what is point E? Point E is clearly 150, 150 comma 0. Okay. Now we have to find the values of C and D. Now if you look at C, C is nothing but intersection of line 1 and so this is line 3. So this is line 3. So clearly it is intersection of line 1 and line 3, that is point C. Now we'll solve it by simultaneous method and find the points. So next is, okay, now to find the two unknown points, that is C and D, to find C and D. So to find C, so I'll just first one is to find C. So the point C, so point C is nothing but it is the intersection of if you observe in the graph, it is the intersection of line 3 and line 1. So if you see, this is the intersection of line 3 here and line 1 is point C. So we'll consider 1 and 3, consider 1 and 3 to find C. Now what is equation 1? 2x plus y is equal to 500. And what is the equation 3? Equation 3 is nothing but y is equal to 250. Now this is line 1, this is line 3. Now we're going to solve these two by using simultaneous method to find the values of C and D. So first to find C, so put y as 200 here, so we get the value of x. So that is 2x plus 250 is equal to 500. So we get 2x is equal to 250, that implies x is equal to 125. So we found the values of x. So y is 250, that is C is nothing but x comma y, that is 125 comma 250. Now similarly we'll find the point C. Second one is to find the point D. Now point D, if you look at the graph, the point D is nothing but intersection of line 1 and line 2. So line 1, line 2 and line 1 intersection is your point D. So consider 1 and line 2 because it is the intersection of line 1 and line 2. Now here line 1 is the same equation 500. So this is line 1. So we consider the line 2, that is x is equal to 150 is line 2. So we solve this by using simultaneous and find the values of x and y. So here we need not use simultaneous method because we already know one of the values, the value of x. So we'll just put the value of x in the equation as 150. So we get 2 into 150 plus y is equal to 500. Now what will be the value of y? Y is equal to 500 minus 300. So y is equal to 200. What is the value of x? X is equal to 150. So now x comma y is equal to what? 150 comma 200, and that is your point, unknown point D. Now we know point D and C. So I'll write the values of point C. C is what? C we found the value is 150 comma 125 comma 250 is. So what is the value of D? Point D we found and we got it as 150 comma 200. So this is 150 comma 200. Now we know all the 5 corner points of the feasible area, that is A, B, C and D. So now we will write the last table. So this is corner points of feasible area or region. So this is z is equal to what is the profit function that we got? So profit function is equal to, profit is equal to 8x plus 5y. Now what are the 4 points? A, B, so A is 0 comma 0, B is B is 0 comma 250, C we just found 125 comma 250, D is 150 comma 200, and last one is E is 150. Just check E once. So 150 comma 0 is the last point. Now we'll substitute, this is nothing but your x comma y. Now we'll put these points in profit function. Now when you put, what do you get? 0. When x is 0, y is 0, profit is going to be 0, and that's quite obvious because when you don't sell anything, your profit is going to be 0. Now next is what? B is 0 comma 250. So when you put x as 0 and y as 250 in profit function, so when you put here, you would get 250 into 5, so that is equal to 1250. So then next is 125 as x, so put x as 125 and y as 250. So when you put x as 125, y as 250, you get 2000, you get 2250. Then we have D. So when you put 200 into 5 gives you 1000, so 1000 plus 150 into 8 plus 1000, so that is the profit for this point is 2200 rupees. The last one is profit is equal to 150 into 8, that gives you 1200 rupees. Now with the 5 corner points and the corresponding profits are given. So one is 0. Now if you're not selling anything, 0 when you are not selling hats of type A, and if you are only selling hats of type B, that is 250 hats, you get 1250 rupees as a profit. And you have C. For C you get 2250. Now, so this is the point that gives you more profits. So profit maximized profit, that is rupees by selling 125 hats of type A and 250 hats of type B. This is the conclusion. Thank you.